Our presentation will be on preventing bin collapse, and our speaker is Tom Nealey. Tom grew up in southeastern Iowa and graduated from Iowa State University in ag engineering. He then went on to complete 39 years with Growmark, where he managed the grain systems, construction, and the engineering areas. Upon retirement, and after a rash of bin problems, he started providing training and investigation services concerning bin problems. Tom is a licensed professional engineer and owner of Ag Facility Engineers, PC, in Bloomington, Illinois. Let's give a big CONVEY 21 welcome to Tom Nealey.
Thank you. So what we're going to talk about is some things that are near and dear to my heart. Like I said, it started about a number of years ago, I'll say, back at Growmark. And at that time, back in the 70s, there were a lot of bin failures. And in fact, I think I got proof that some of the bin gauging on the bins was created by the marketing departments rather than the engineers, because there were no engineers in some of those companies back then. And so you would have a bin problem, and the answer was, well, let's just put in a bigger ring. Let's put in one a little heavier. And nobody would really analyze it. So it's been kind of a hobby of mine for 40 years, and so kind of jumped in when we had some problems developing, got some of the old equipment out and started working on it again. And I called in my trusty helper right here. This is Warren Odekirk, who's about 40-some years at Growmark. Yes, we are the old ones. And between us, we've probably been in about 100 bin failures, different doors popping out, sidewalls wrinkling, roofs coming apart, those types of things. And so we've kind of been doing this and having a little bit of fun with it. He retired, and they asked him to come back to work at Growmark, so he's kind of part-time. Me, they didn't ask. I haven't got that all figured out yet, but I didn't get asked, but he has been working. But we try to do this a little bit on the side and have a little bit of fun, keep our minds active with it. So we are going to be showing you what goes on in a grain bin. This is a program that we put together to go out and talk to grain operators. And we've done it a number of times over the last 2 or 3 years. And actually the yard help come in, and so we're going to be going through what we show them, and then we were asked to carry it on a little bit further into what other bin collapse type problems we could get into. So with that, we'll try to get underway. Start off the loading and unloading. I recently ran across information with Nationwide Insurance, and the number one failure of grain bins, wind. Number 2, unloading off center. And so that's like 26% of the failures was unloading off of center. So that's what we're going to try to be talking about with these models we've got up here. We'll try to make it a little bit more interactive. When we start doing it, if people want to get the center to see better, you feel free to get up. We're always going to talk about some of the age problems, some of the construction issues, but this unloading is the number one thing we're going to concentrate on. So, got a question. Okay, boy, this thing is quick. Here's some pictures. New Carlisle, Ohio, January 22nd, 2018. That's from the TV. Big bin collapse. You see, it took out the end of the office. What a mess. Luckily, no one injured. Happened in the middle of the night. Wiped everything out. Big damage. Here's one over here from Melbourne, Australia. And one of the things I'd like to point out on all of these is that not only look at the damage, but look at the ongoing damage and the cost of repair. When you've got this, you've also got the other bin next to it that's got $100,000 of repair to it. And with the age of the facilities, does it make sense? So, I mean, it's big dollars when we have a repair like this. And last one, this back my hometown. Now, there's argument whether or not it's Dodgeville or Danville, but I'm claiming it right now. But back in 1921, the elevator came down. It's funny, these things have been going on for a long time. Back to the turn of the Industrial Revolution, when we started doing bins for iron ore, coal, flour, grain, whatever, this has been a phenomenon that's been going on for some time. It happens everywhere. It's not isolated to the Midwest. It's any product, anytime you've got a bin, anywhere, it can happen. And when it does, it makes big news. And the big thing we try to stress with everyone, every one of you has the power to cause one of these failures right in your hand, right here. You can cause that by pulling the wrong gate, by pushing the wrong button. It could be you that caused that, and you're the one that might be getting interviewed on the TV. So with that, kind of set the stage. Which of these is most closely related to a grain bin? Everybody's speaking up at once, so I'll ask it. Who votes for number one, the box? A good smart group here today. No one chose that one. Number two, the grain bin. We got voters? Yeah, several. And number three, the balloon. Yeah, it's kind of tied. Okay, let's look. Doggone, that's jumpy. Okay, first of all, on the box. It's got corners, it's square, it's very inefficient for storing grain. You got to have the walls strong enough to hold the grain from bending it out. And you've got corners in it that are going to rip out because of the moment that your concentration in the corners. Box is not a real efficient way. It doesn't have that hoop strength like you do in a grain bin, a round structure. So number one is out of here. Number two is the grain bin versus the tin can. The average tin can, if you measure, it's about just a hair less than 4 inches. And that's 30 gauge material. Now, if you take that same dimension and scale it up to a 48-foot diameter bin, that's 1.5 inches thick steel. It's a bad day to be on the bin crew, I will tell you that right now. 1.5 inch thick steel sheets to be comparable to that tin can. And so no, the answer is number three. It's a membrane. It's going to take the shape of what's going on inside of it. And if you don't believe that, look at these kinds of things. This is taking on the shape of what's going on inside the grain bin. You can see on the one on the left, see those ripples right here? The top of the bin's leaning over towards the other. And that thing, the sidewall is being drugged down, is going clear out around the rest of the bin out here. The other one is self-evident with the big failure right here in the side of that taller tank. Those are what we have happening inside that's causing a void in there. And so we're going to talk about those for just a second as we talk what goes on inside the grain bin. A water tank is very simple. Water has no friction on itself. It doesn't have it won't stand up. Whereas grain is a bulk commodity. It's got friction inside of there. It's got friction on the walls. It's got pressure different than a fluid. With a fluid, it's equal all the way down. The deeper you get, the more the pressure. With a grain bin, it kind of levels off. You've got a lot more vertical pressure coming down. And so it's two different kinds of structures when you think they're the same. This has a lot of stuff going on in it. It's like a bobcat inside of a burlap bag. There's stuff going on inside of there. And so trying to resist that is the challenge with the engineer. So we're going to show you just a second how a normal bin should be unloaded. These are plastic beads like I said, if you want to get around to where you can see them better, you're sure welcome to. And we need to have somebody in charge. Maybe you would help us. One of the things, no, just stay right there. One of the things we have happen is we get excited talking about it and we forget to move the buckets underneath. And the hotels are not very appreciative of that after a couple times. So we're going to drop this out and show what goes on as you unload a grain bin. Okay, we're unloading it right out of the center. Okay, notice it's starting to come down at the top, but see this angle right in here that's forming? That's the shear angle. The grain on the outside of it is not moving, it's stationary, and this inside is moving. So you got this shear angle coming up. So it all funnel right down. Now up at the top, that's your emptying angle of repose. That's different than when you're filling. When you're filling, there's a lot of energy coming down, depending on how high the spout is, and it can blast it away. But this is just gravity and from itself like that. And so that's the angle of repose. This is liquid, essentially. Think of it as liquid. If you step in that, it's going to suck you in like quicksand. All around the edge of it, you've got moving grain. Very, very dangerous. You'll drop right into this flow. So you can see better right along in here is that shear line where the grain is actually breaking loose. And that varies on what type of product you have in the bin, whether you've got ball bearings or sawdust. It's going to have a different type of a bearing on how the angle of that unloads. Okay. I'll let that run on out.
Okay.
Well, okay, now let's refill it and we'll pull the other side. As you saw, at the center of that bin, once we pulled the cork at the bottom, all of a sudden you've got a void forming. And that void, it starts collapsing. Have ever you felt a grain bin or seen it happen on a bin wall where it's unloading and it's like jumping? You have that vibration in the bin that's happening. It's actually that grain breaking loose as it comes down. It's unloading. How's it going back here? Vanna? Yeah. So it's kind of breaking loose. It goes all the way up and then starts running in from the top. So that's what a standard, typical bin should unload like. And as you saw along the side, there was no wall movement. All the grain was just rolling in from the top. So there really wasn't that much additional stress on the bin other than just rolling in from the top. It wasn't like it was sliding on it. Okay, now, let's say we're going to unload it from over here. Got the same thing happening, but now we've got all of this moving grain. Remember, I said that's liquid. That doesn't have that pressure pushing out like the other did. Think of it as a liquid. All that is all along the side of this bin wall. And when we do that is when we get in trouble, because then you don't have an equal pressure pushing out all over the grain bin to make it stand even. You've got an imbalance of load. So let that one go on. You can see that angle of repose a little bit easier on this one, a little bit better measurement. And that is a good indicator of the friction inside the grain that the grain bin engineers actually use to calculate the loads on the walls. I think that. I'll let that run on down a second. So typically, if this happens, we've got a bin unloading from the side, one of the wells out closer to the wall. Doesn't have to be right close to the wall. It can be in a little bit and still do the same damage as long as that is intersecting with the wall of the bin, that funnel. So typically that's what's going to happen is you've got that. And why does it happen? Number one is probably the center fill didn't work. And so we have to go outside or the center unload doesn't work. So we have to move out to get the grain out. It's plugged in the center. So we're going to move out, do it, and boom, that's what happens. We see it where gates have been left open in the bin in the fall. They filled it up, didn't know what it was unopened like that, start unloading the grain. That starts pulling the grain off of that sidewall. So those are when the damages start occurring. Okay, we've got a grain bin loaded right here. This is a plastic bin. It's got a few wrinkles, but it shouldn't matter much. It's got sand in it. So what I'm going to do is show you the inlet is just on the inside of that wall a little ways. I'm going to pull the cork on it here. We okay? I'm going to pull the cork on it. I'm going to shut it off right away then. So here I go. You see immediately the walls of that grain bin came down just milliseconds after it opened. That's because that first initial moving out of the bin, that void in there, nothing was stiffening that wall, and all the strength in that wall was flattening it. And so it just collapsed. Plus you've got all of this grain weight on the wall, friction above it. So immediately, here we've got a substantial dent in that one, moved right on up here, and it's going clear around the grain bin on both sides of it. So making a mess out of this grain bin in just a short time. And Warren, I think you had it happen with a grain bin with a very small opening in it too, as we talk about what the flow rate it takes to do this. I'm going to go ahead and uncork this.
We had a bin failure, well, it's been 20 years ago now, down in southern Illinois. But it was a commercial bin that had been there quite a while. And it was 18 rings tall, and the top 12 rings ripped off and fell on the ground. Took out all the bucket elevators, electric control center, catwalks and conveyors, the whole thing. So we got called in to do an investigation, and we brought up the engineers from the bin company. And the bin had been cleaned out and vacked out, and it was totally empty. And we were walking around inside the remaining 6 rings trying to figure out what was going on, and I stepped along the wall, and I damn near broke my ankle. It went in a hole. I stepped back and said, "What the heck is that?" And we shoveled the corn away, and it had a U-trough screw conveyor unload under the bin. It was the inspection plate for the hanger bearing. And the crew had been in the bin and greased the hanger bearings, and they forgot to put the inspection plate over the top of the hanger bearing. And the operations guy came up to me afterwards and says, "You know, I wondered why I couldn't shut the center well off." He said, "I never could get that screw to clean out." And we stood back, and it was an internally stiffened bin, so the stiffeners were painted. And you could see, once you knew what you were looking for, the angle repose right up the stiffeners. And it took all the paint off the sidewall of the stiffeners. And it had been like that for about 4 years. And when she went, it just went completely. The bin was full. Like I say, took out the whole elevator. But it was a hanger bearing plate that was about, about 6 inches wide and about 14 inches long. And that's what it took to take out the tank, right next to the sidewall. So,
While Warren was going through that, you might have noticed there was a big dent that got worse there for a minute. Now it's kind of popped free. But the damage up along the side of the bin has continued through the rest of it. One of the exercises we do, we're not going to do here, but we get a rope tied in a circle and get about 4 or 5 people inside of it. Everybody pushes outward. And we ask, what will happen if one person lets go? And that wall immediately flattens in and the others go out. And that's exactly what happens in a grain bin when this happens. So you see the over here it was moving, over here it was moving, here it was flattening in. And if you get at the right angle, there's a huge flat spot up the side of this bin right now. So if you have a bin roof hooked to the top of this, that's what it's going to look like if the bin roof was still connected. So you'll see that turned out on the top of a bin quite often. Get the rest of this out here. Here are some things you will see out in the country. I know they're not at any of your facilities. I understand that. These were other people's. But this was a bin. You can see how they're unloading it with an auger out of the bin door, the walk door down there. And look what happened right up here. The whole bin around the back was messed up, and the whole thing, it had to be replaced by unloading out that door. Here you see one that, well, the millwright even went to some extra perfection. They've got that fill that goes down the conveyor, and they can actually see it rolling out of there. I mean, that's a nice piece of engineering. It not very sound to be doing, but it's good work. Or you can kind of homemake them yourself, just a piece of spout in the side of them. And they had the forethought to put a couple reinforcing steel pieces across there to reinforce it. I don't know what that did for them, but they could collapse the whole side of the bin, any one of these. And the funny thing about it is I had to go out yesterday morning and fill this up in my garage just to be sure it would work. Sometimes they don't work. And sometimes people get by with those in the country for years and years and years. Then one year, real heavy corn, a real dry, real flowing corn, and you'll see one pop loose like that. So, yeah. Do not put unloads in the sides of the bins. Dang. There we go. Here's another. Warren and I were out on a call a while back on a problem you'll see a little bit later. But this is a manufacturer gate they had down in the bottom of the bin. They claimed that they used it to get some of that last little bit of grain out after it's. We never use that. We never use that gate, to unload the bin. It's only after it's all unloaded and we're just cleaning out we use that. However, if you looked up the side of the bin wall, see that up there? It's just what I was showing up here on the top of this bin. It's flattening out the side of the bin roof is holding it stiff, and it's wrinkling the top ring of the bin with that little mechanism down there in the corner. So really challenge any additions to the bins. Preventing bin collapse would, number one, say don't put any of those types of things in that allows people to draw it from anywhere but the center of the bin. Now there's another disturbing thing about this too, is that when you do this, quite often it's the manufacturer can determine what you did. So it's not like you can get by, well, I don't know what happened out here, but I don't know. It just, age of the bin, I guess, fell apart. No, the bin has a pattern on it. Number one is you probably see it happening right over the unloading tunnel. And you'll see the openings, the damage right in line with it. And number two, there's shiny steel on the inside of the bin because the grain has been moving down it. It hasn't been rolling in from the top. So that shine on the bin, it's slicked up. And so when that happens, they say, you're on your own. This was a good bin when we left it here. You're on your own because we know what you did at this point. Here is one ever so happened to. Notice the indentation right over the tunnel. Okay? Right here we've got a flat spot indented over the tunnel, which is the first indicator. Sure enough, it had been unloaded not from the center. And look at the damage on this. It's shearing those bolts out on that horizontal seam. It's popping the bolts free. You can see grain leaking out, which is never a good thing. It gets worse when that happens. And look at the amount of stretch you've got of shearing bolts and that much elongation coming out in those seams. And again, you can see that better from the side, the buckle in the sidewall. So all of that was caused by simply pulling the wrong gate. So warn the guys, do what you can to keep from pulling the wrong gate. Now the question I always ask is, well, how are you supposed to do it if you want to side draw unload. Well, for many, many years, and I wish I would have invented this thing. This is pretty cool. This is our makeup of a side draw unloading flume. Never really understand how they work till you see them work like this. But this is how you keep that from happening. So if you're going to be unloading from the side of the bin, that'll work. We'll load this back up and show you how these work. It's not going to work. Yeah. Uh-oh. That's good enough. Okay, so now we've got our flume. Let's say we've got a side draw coming out here for a truckload. This is what you would be buying as a package with your grain bin dealer. So we're going to pull the plug and watch how that's supposed to work. Is that rolling in from the top? That's the slickest deal. It keeps it from rolling in underneath and creating that big liquid spot, I'll call it, on the side of the wall. Instead, it keeps it concentrated to a small area, and it actually comes right on, rolls in from the top. There we go. Just keeps unloading nice and evenly like that. It doesn't come in underneath here anywhere. It all just flows in from the top. So that's what it takes if you're wanting to unload a bin from anywhere but the center. No ifs, ands, buts. That's what it takes if you're not wanting to unload from the center. Said it just kind of increases the opportunity to bring it in by gravity. It shortens up the area it's exposed on the wall to do any damage, and it just keeps rolling in. One other area that we've seen problems in is once you get that bin gravitied out from the center, then you've got this big inverted, opposite of a triangle or cone, whatever you'd say, in there at that point. And the uneven pressure that you have in a bin will still exist even after you've unloaded out of the center. So you need to be careful with this as well. You've got the same situation when you start taking the grain off of that side, that you've got a void along that wall and all the rest of the bin is pushing outward, but that has nothing to hold it. So it's going to suck in. It can actually move your grain bin wall, take it right in off your anchorage, doing it just with the last bit of the unload. Here's a couple projects we've both been involved in. This is one number of years ago. It's a 48-foot tank. They used Redhead Anchors in it. Fresh concrete. This is like in September when the bin was built. Pretty good size tank, but they used the Redheads and had new concrete, and had a one-pass sweep. And as the bin got over in this area, it popped one of those anchors. That wall opened up, sucked in, and actually popped one of those anchors out. It then went to the next one. Well, we got twice the load there suddenly. It popped it out. It did the next one. It walked right around the bin until it actually walked right off of the foundation of the bin. So it moved it all that much just by having that anchor pop free. and it was not necessarily designed for a one-pass sweep that they had put into it. The other issue you have is on the one-pass or the two-pass sweep, people don't want to do that. They don't want to have to get in there. We don't want them getting in the grain bin. And so we'll put a one-pass sweep in there. And remember, the two-pass sweep is there to reduce that overall height and keep it somewhat even. You do that with a one-pass, and you're eliminating that opportunity. Here's a bin we were on a number of years ago. It was a potential purchase, and they're wanting to look at the bins, and well, this had a flat spot on the side of the bin right over the unloader. We thought it'd been, side draw off-center unloading some way. Actually was ripping the stiffeners right out of the sheets, 105-foot tank. And of course, we told the buyer what we'd seen and stuff, but when you're wanting to buy something, you guys know how that is. It's like a new car. They ignore the details sometime and go on with it. Well, Warren was out there this last year, and I think he found out the problem with it. It was a one-pass sweep in a bin not designed for it.
Yeah, this was an old Brock Butler bin, which was not set up to be used with a single-pass sweep. It did not have the extra base anchor clips that Brock would normally require in their construction manual, so it's not the bin's fault. But they put in a Hutchinson single-pass sweep, and they ran it all the way around the bin, and it had again done this for about 6 or 7 years. And have you got pictures of it where it ripped it loose?
No.
It basically took all the stiffener base plates that you see there, and where they were welded over the reclaim tunnel and they started up the sweep, it ripped them all loose, broke all the welds, sucked the base plates in about a foot, and on the opposite side, on the other side of the tunnel, it also ripped them loose from the anchor bolts. It sheared about 30 of the 105 divided by 35 sheets. There were about 70 anchor bolts in there, sheared about 35 of them off. And basically, the contractors had to come in, stretch the bin back into round position. They had to put hydraulic rams on the inside, put anchors in, push the bin back out into a round position. Since the anchor bolts were sheared, they had to put extensions on the base plates, double anchor it, and round it back out. And that's one of the things, again, as you talk about retrofitting, and especially with all the OSHA emphasis on zero-entry sweeps now, if your bin is much older than 10, 12 years, it's a pretty good chance it wasn't designed for a single-pass sweep. You got an old Chicago Eastern, you've got the old MFS bins, you've got some of the old Butler bins. At that time, they didn't worry about single-pass sweeps. And we have seen more than one bin where, somebody came back in, put a single-pass sweep in, took the double-pass sweep out, and it rips the anchors out and sucks the sidewall of the bin in. So you got to be real conscious of that as you're looking at that. If the bin manufacturer is still in business, give them a call, talk to their engineers, find out what's required. If it's an old bin, there's some of us around that have history files on a lot of this old stuff, and we can tell you what the recommendations were. But this wasn't that old of a bin, and it pretty much made it unusable until the repairs were made. So,
Got it.
you want me to?
If you can fill her up the rest of the way.
Okay.
Another issue is filling the bin off-center. And here I've got a grain bin only anchored on one side so you can see the movement. Let me borrow that for me for a minute. Kind of get it. Okay, I'm just going to load it as if we were filling it through the man hatch on top of the grain bin roof. Notice it bulging out. At this point, it's starting, it's going to run over the top. This indented, it's going to come out over the top of the bin sheets. It's stretching it into an egg shape. Now, what I want to show you next is I'm going to try straightening it out by filling it in the center. It doesn't move it a bit. I could keep filling that on up, and it's still going to have that same problem. Once you go in the center, once it's out of shape, you can't push that back into shape. Grain has a characteristic of it's either active or passive pressures, they refer to them, and it pushes out at one pressure, but when you try pushing on it, it resists at a higher pressure. So you're going to have a bend distortion. You can't push it back into place, and the size of the load is immense on these grain bins. You get a bigger diameter. Here's an example of what could happen. You see bins like this with the bolts right out the side of the foundation. So I don't know, maybe the conduit's holding it together. I don't know, there's a lot of conduit. But that's going to happen from being either the bin wasn't round, one of the things we look at in construction, or the design, was it at the right radius, or was it filled off center? We're involved in a bin several years ago too that had this kind of a story to it. It was unloading. It was a very large tank, like 150-foot diameter, and the operator thought that there was so much grain on one side of the wall that I better let some of the pressure off. So I'm going to lower the grain on that opposite side. So he essentially created a tunnel in the center of this bin. And what I was showing you here is exactly what started happening. Because there was no grain to keep that bin shaped evenly, it started going out on the ends and trying to egg shape really badly. You can see with, we can recreate this pretty closely. Yeah, can you get another bucket under that? We're going to do the same thing here. I think that should be enough. Okay, we're going to start unloading. Okay, we're taking it down one side. We get it down a ways. And then the operator thought, that grain is standing up tall. I better do something differently. So at that point he came in, got the other bucket. Not doing your job. It's a close call. There we go. Now we're going to take both of these down. And just wait for it. There it goes. See it just start folding up? It's exactly what that grain bin did. Just folded up, exactly like we're showing there. You could actually see the anchors where they were ripped and tearing loose. If you looked at all the anchors on the bin, they were in a pattern. East, north, south, west, they all just stayed square to each other, but all the rest of them were pulling at an oblong shape. See, actually the bolts and the stiffeners aren't even lined up now, and you could see that dent along the side of the bin. So keep the bin pressure even as much as possible. Okay, now we've been doing something with all these were what we call a shallow bin. Now I want to show you what happens with a deep bin. That one right there, Warren. Okay, we talked about on that last bin, remember, how it unloaded from the top and rolled in? Well, this is a different shaped bin. This is more of a tall silo. Watch how it unloads. A little different shape to it. It all comes down evenly. It just flows down evenly. There's none of this rolling in. This is mass flow unloading. If you've got a tall silo, that's what's going on in it. It's coming down evenly. And the difference between this and the last one was the first bin where it came in from the top, the last grain in on top is the first to go out. It rolls down and goes out. In this one, the first grain in the bottom is the first to go out. So it goes all down. Now I missed it as we went by. But there was a funnel, a natural funnel formed in here. And that is a very critical part. On the pressure on this grain bin, it's like I showed earlier, the pressure on the grain bin kind of accumulates and levels off, pushing out. But you get to the top of that cone, and that's where it's like putting your thumb over a hose, and the pressure is going to push out right at that point. So you've got a spike in pressure right at the top of that cone, right about in this area, right in through here. Two things to notice. Well, there's three things to notice on this. One is I think that's a soccer net, is where the one thing you're looking at. The other is the grain bin wrinkle on the harvest door. Not sure what happened other than that would be the typical place. And the third thing to notice is that door on the side of that concrete bin. Obviously, you want the door up so you can see over that grain. You can get access to get things in. You don't want the grain in front of it. But that is absolutely the worst place in that whole bin you could put that door, right at that spot where we need them. And so it's very, very critical to not go and cut in that area or do unsanctioned type work in that area, because that's trying to work as a belt. That steel is right in that high pressure area. You cut the belt and you've got a problem. Here's a bin that's getting its belts cut. It's a concrete tank that's actually all of the cover is coming off of the steel. And so when that happens, there's not much strength left. There's nothing for that steel to grab to. You can see vertical cracks developing. Very bad situation where we're losing the strength of those sidewalls. Dang, I can't do it. There it is. So all of those reinforcing steels that were running where that door or where those openings are needs to be carried through to the other side of that wall. So if you've got, let's say, 3 in this case, or if you've got 20 reinforcing steels, that same amount of steel would have to be carried through that door frame to maintain that. And not only carried through the door frame, but stiff enough so that it doesn't bend in that door frame. So it needs to be rigid enough. So bottom line, do not cut in there without an engineer familiar with the structural design of that kind of a thing. Do not let the millwright start cutting holes in the side of it. It's not a good thing. I'm going to get into some of the aging things right now. Actually, could do that other tall one if you got it. Okay. We'll see if we need it. Here's a bin with legitimate side draw unloading. But again, with age on the bin, notice all of the cracking around this spout edge up here. All of that is carried, continuing right on down the rest of that sheet. And part of that is just age, rusting, dirty grain sitting below it, and age working in that bin wall, because that would be an area where it would be fluttering movement of the grain. So very prone to cracking like that, plus it's a weld along that line, so it's going to be more prone to it. So do not overlook looking at your bins in any sort of sharp area like that where you got a discontinuity. One of the things you can do to show a little bit of this is blow a balloon halfway up, put a Band-Aid on it, blow it the rest of the way up. What do you got? You've got a stress concentration right there. It's going to change the shape of it. So that door needs to be designed with the bin. It shouldn't be done by somebody else. You need to keep it the same. Here's another, as we talk about how to keep a bin from collapsing, another age issue. Talked about when we started back in the 70s, there was a lot of grain bins added to the system back in then that are getting, 50 years old. And you see this one right here. This had a crack going right from this sheet, right down this one, through this sheet. So they thought they would patch it up. So they put a piece of galvanized steel over it and put some self-drilling screws in it. That added a lot of structure to it. So it continued right on. Well, actually, it was a small break right at that point when they put the patch on it, so give them credit. It grew after they did that, but it actually took off on them. And if you get close to this, I don't think I've got a picture of it, but you can see the sheared off and slid about a half an inch probably around those little self-drillers. Well, there it is. There you can see it. Doggone it. There's the movement on that little patch where there's no structural common sense to it. It was a patch, that's all it was. They needed something more structural. And the other part of it is you see black goo coming out from behind the sheets. Anytime you see black goo on the bin wall, you know it's not a good day for the bin. It's dripping down the side of the bin. And further proof of that, this is the inside of the bin when they got it empty. And see those light spots in there? See that? All those? That is when they were cleaning the spoiled grain off the side of the bin. They actually rammed the hoe through the sidewall of the sheets. They actually went through the sheets. They were that thin on the grain bin at that point, that rusty and worn. So they had a center fill plug. That's why we were involved trying to figure out what to do with the patch and how to get it unloaded. We ended up recommending what they did was did the can opener thing where we started at the top and unloaded it and just took it down until it got low enough to get a vac in there and get the rest of it out. So it was not a good day. Other aging issues. You look at the bottoms of the bins. See you can see black goo down there sometimes too, but you see there's been a lot of it around there. You see it start aging, start cracking, start moving up the bin wall. Get it replaced. Warren, talk about these a little bit. They're old internal stiffeners.
Yeah, one of the things we're seeing a lot of, especially, this summer it seemed to really hit, but a lot of these bins that were manufactured with internal stiffeners were tarred on the outside, maybe tarred on the inside, but the stiffeners have completely rusted away. The anchor bolts are gone. And I went in on the bin on the right, pictures, and just took a claw hammer and went around and started hitting the anchor bolts, and I busted about half of them off, just hitting them with a claw hammer. They were completely rusted. And when you look at the galvanizing or the thickness of the steel, you could physically see the steel had scaled away. You could take a putty knife and actually start scraping the stiffeners with a putty knife, and the scale would just fall off, and they were probably half the thickness. Both of these bins failed. And, the stiffener on the left, it's a Z stiffener, it buckled and rolled. And there was about 7 stiffeners in a row here that did. The bin on the right, the whole foundation ring was gone when they got it out. And, unfortunately, not very many bin manufacturers are making the Z-style internal stiffeners anymore. So you either got to work with a millwright who knows how to adapt a new style stiffener in there, or we have a fabricator that we work with that can fabricate the old style stiffeners to put in as replacement. But You need to be, when your guys are in sweeping the bins out and cleaning them out, they need to be really looking at the bottoms of these stiffeners, and if they see any scale whatsoever, like you can walk up with a putty knife and you can scrape it and it starts scaling rust off, you got a problem with that stiffener. You're starting to lose your strength, and all your vertical load is coming to a point right there where they're going to fail. So.
Another place, we've all seen it, is around the door openings. You see it accumulating. Bad spot for rust. Again, any inconsistently in the bin, like a frame or an opening, anything, a sharp area like that, be looking for potential rust damage. And another one is concrete. We'll wrap up a little bit on it. This first one here is a bin that I can tell right now that nobody designed it, because there's hardly any reinforcing steel, and they're expecting to carry the full load of those stiffeners right over the top of that tunnel. It's stood there 40 years probably, but I'm sure there was no official design in that thing when it was put in. It's starting to break away, weaken. You see age. You see things like this, whether it was like we talked before, just bad concrete, or if it was something on the radius that was in that bin incorrect. One of those two things could be happening. But here's the final one we really want to talk about. This is a new bin, brand new. And we've got concrete cracking all the way around here, and serious cracking, as you can see on both sides. And you can see right down the top of here, this whole thing is trying to break out. What best can be told of it? There were going to be 2 bins on the site, and they did the soil borings on one bin site. Then they decided to build it on the other site with the same information. So it wasn't necessarily for the borings at that site. So there could be some inconsistencies in the ground down in that area, but the structural engineers that were called in identified a lack of steel in the wall, in the anchorage of it, where, remember that bin wall I showed you with the concrete exposed steel? It takes a certain amount of what they call development strength for that. You have to have that anchored in concrete before you can actually get the full strength out of that steel rod. And here they didn't. They suspicion there's not enough in this vertical face, and it's starting to come apart and break. And also the center of the bin is maybe not handled properly in its fill. So go ahead.
In this example, went down 4 more inches than the footing. And a lot of times everybody gets concerned about the bearing strength under the footing, and they forget about the bearing strength underneath the center of the tank. And you guys have all got big tanks. You know how you walk in and you're dry at the stem wall, but you get into the center sump and the water's over your toes or your boots, and then you walk back up because the center of the bin settles more. And this was fish bowling, and so at the same time it was pulling the stem wall over, and because there wasn't enough rebar in there, it's starting to blow that wall out. So.
And here is one other final slide on one of the biggest issues we see right now is trying to expand a system or replace a system. In this case, they put on how big an unloading, Warren?
Yeah, this had a 10,000 bushel an hour conveyor, and they took the bridge and the conveyor down and put a 20,000 up on top. And this happened to be a Chicago Eastern tank, and Chicago Eastern tanks had a 2,000-pound peak load maximum. And you guys know if you're building new 105s today, you're probably getting 50,000-pound peak loads maximum. And the manufacturers are even jumping up 75,000, 100,000-pound plus peak loads. This was 2,000 pounds. It didn't make it through the first winter. It's up northern Illinois. So they had to come back and basically Again, it's a Chicago Eastern, no roof available, so unless they take it down, put a brand new roof of somebody else's manufacturer up there, that tank is junk now. So they've not been able to use it the last couple of years. So, again, if you're looking at expanding your facility and increasing your capacities, talk to the bin manufacturers, find out what their peak loading is. Again, they're not all created equal. I know GSI has 2 or 3 different peak loadings. Brock back in the day had 2 or 3 different peak loadings, whether it was a Brock Butler or a Brock. Check with the engineers and find out what your tank can do before you end up with something like this.
And in summary, look at that, right on schedule, guys. I'm getting thirsty too. So anyway, operation, probably the biggest area of failure on your grain bins. Center fill, center unload, proper aeration. It was once said that the only reason we aerate, there's only one reason. That's so we can get the grain back out of it again once we put it in there. Otherwise, it's going to be a spoiled blob. So, proper aeration, everything Dirk talked about. Age and wear, the steel thickness, look at the door frames, the openings, wear and tear, where the unloads, where there's movement, where it could be cracking. Like I said, the crumbling, the condition of the concrete. And lastly, the roof loadings. Those are being exceeded out here on a lot of these newer constructions on the old bins. Use engineered foundations, reputable engineered foundations, and don't cut any openings in the sidewall unless you have somebody that knows what they're doing from the bin manufacturer or a structural engineer assisting you with that. So those are the highlights of what we've been trying to get across. And we're looking at 1, 2, 3. We're there right now.
Oh, well, does anybody have a question before we close it? Everybody, okay, here we go.
Dumb question. If you use the side draw and you're using the side draw, then you decide to switch and use the center, can you do that safely?
Yeah, Warren, you want to answer that? I'm just the big idea guy. This is the detail man here, so that's...
Yeah, most manufacturers will recommend if you're using your side draw and you stop anywhere in the process of unloading the side draw, before you refill that tank, they want you to pull the center well and core the tank back out. Because even with the side draw flume, the bin is going to go out around. It's going to try to egg. And as Tom showed with this demonstration, once it starts to egg, you can't put it back into shape. So if you've been side drawing and it's egged ever so slightly, and you start loading it back up again, the next time you side draw, now it eggs a little bit more. And you keep egging it, and you'll start to see a flat spot right in here where your side draws are. Pull the center well, bring it down. You don't have to empty the bin, but you got to balance the load around it. Then you fill it back up, and then you start in again. And you cycle the bin that way.
Bottom line is it'd be good for the bin to do what you're talking about.
Yeah, I see a lot of guys that want to do working tanks, and they do a working tank where they put a side draw in it, and they're going to load rail. And they want to flush the grain through the tank. You know, we're going to load a rail car. We're just going to keep dumping grain in on top. You're going to pull that wall in, and eventually you're going to stress that tank and have troubles if you don't core it. There's not very many manufacturers that will let you go more than one cycle. I know, Steve, you're here. Sukup, do you still recommend one cycle on your side draws? Yep. And only 1 or 2 that might let you do a couple.
Okay, let's have big thanks to Tom and Warren.